Good morning. In this session, we are going to relate the chemical processes occurring in the lead acid accumulator. As previously described, the lead acid accumulator is a secondary rechargeable cell. Within the lead acid accumulator, we have three main components. The anode is mainly a paste of lead 4 oxide. The cathode is a rod of lead, and the electrolyte is concentrated sulfuric 6 acid. In this respect, therefore, we expect that the first reaction would be the oxidation process, which happens to occur at the cathode. During the oxidation process, the lead rod simply dissolves into the electrolyte, thereby giving out two free electrons. These free electrons are readily transferred to the anode. At the anode, they meet the lead 4 ions, which are dissociated from what we have there as lead 4 oxide. Now, once the lead 4 oxide meets the delocalized electrons, they are readily reduced, and through the reduction process, they precipitate lead 2 ions. The lead 2 ions becomes the active agents for the successive reaction processes. In this respect, therefore, the lead 2 ions meet the sulfate ions from the electrolyte, sulfuric acid, and when the reaction occurs, they precipitate mainly lead sulfate, an insoluble substance which is not readily reversible. In that respect, therefore, once lead sulfate has formed, we assume that the cell is depleted. Now, when the cell is depleted, it means no further reactions occur. And therefore, we need a mechanism of recharging the cell. To recharge the cell, we simply need water. In this case, the lead acid accumulator is referred to as a wet cell simply because when the reactions are complete and the cell is depleted, it is rechargeable by simply wetting it by adding water. In this respect, we see that when lead sulfate, which is the highly insoluble precipitate in the lead acid accumulator, meets water, a successive reaction occurs producing lead 4 oxide, lead, and aqueous sulfuric 6 acid. When you look at this product keenly, you realize that lead 4 oxide happened to have been the anode in the cell. Secondly, lead happened to have been the cathode. And thirdly, the sulfuric acid happened to have been the electrolyte. Now, this simply shows that the main reagents of the cell before the beginning of its use and reactions have been regenerated. And the regeneration process is what we are calling a recharge. This recharge has been effected simply by hydrolysis. The hydrolysis process of adding water to the insoluble lead sulfate precipitated during the lead acid cell reaction reverses the process and forms the initial raw materials, namely an anode composed of lead 4 oxide, a cathode composed of lead, and the electrolyte composed of sulfuric 6 acid. The only unique property is that the sulfuric acid precipitated after the discharge is a dilute solution. It is no longer concentrated, and that shows us that the cell may not operate at optimum conditions simply because the previous electrolyte before the cell reactions happened to have been concentrated, but the recharged cell has the electrolyte in a dilute state. However, it will still function, only that it will function for a while. So therefore, we have seen here what we are calling the lead acid accumulator, which we have categorically described as a secondary rechargeable cell. The bone of contention as to why referring to it as a secondary cell simply because it is a cell which is rechargeable. And secondly, it is a wet cell simply because it's rechargeable by hydrolysis. Thank you very much.